Okay, let's start by reviewing and reminding ourselves, and so that we never forget this. An expression is not considered simplified if it has what type of exponent?
Negative.
That's right, if it has negative or zero exponents. You don't get to stop simplifying until those are gone. So, give me an example of a fraction, just in our, before we even started talking about these negative and zero and whatever exponents. Give me an example of a fraction that if the direction said, give your answer as a simplified answer, and you gave this fraction answer, I would have to count it wrong. Give me an example of that. Josh?
1 over 2 to the negative third power.
Okay, you didn't listen to my question.
2/4.
2/4, thank you, Devin.
Not simple.
Not simplified fraction was what I was asking for. So before we even start talking about these exponents, if you were in an assignment or a quiz, you were told to simplify, give the simplified answer, and you gave your answer as 2/4, would I have a right to count that wrong?
Yes.
Yes, because what can that be simplified to?
1/2.
1/2. So the same thing happens with negative and zero exponents. We have to make sure that there are none of those left in the expression, whether it's an algebraic expression or a numerical expression, there can't be any of those left to be considered simplified. So when you did for A, how did you go about that one? What did you do to simplify that one?
Well, I know that R to the 0 is 1. So
You know that R to the 0 is 1, so you renamed R to the 0 as 1, okay? So then, let's just stick with yours for a moment here, Devin, and say, I'm just gonna write down, you guys don't have to write in your notes quite yet, but it sounds to me like Devin made the R to the 0 power 1, okay? What else did you do with that?
well, I kept it as 2 for the first
Kept it as 2 because you said there's nothing needed to be simplified
one.
there?
And then I put 1 over M3.
And then 1 over m to the third, not m3. M to the third power, or m cubed, okay? And then what did you do?
Well, and then I took 2 times 1 because that's 2.
You took 2 times 1 because that's 2, okay. And then,
I just put 2 over 1 and then multiplied those 2.
okay, and got
2 over M to the third power.
2 over m to the third power. Does that look like anybody else is in here? Yeah? Okay, anybody have another way you went about it? Anybody do it any other way? Is this simplified? 2 over m to the third power? How can you be certain it's simplified? How can you say to yourself, there is nothing else I can do? What are you going to check for? What do you need to check for? You got to kind of like go through this, checklist of, like if 2/4 is a simplified fraction, what checklist would you go through there?
I'm hoping 2.
You say, can both of them still be divided by something, right? So 2 and 4 can both still be divided by 2, so you would say, well, then I can't say I'm done yet, I gotta keep simplifying. How do we know, what kind of a checklist could we go through here to say that is simplified?
Make sure you don't have any negative or zero exponents.
Make sure we don't have any negative or zero exponents, okay? Anything else? It's a fraction. What else might we probably better check for?
If it's reciprocal, make it
If it's what?
reciprocal, make it 1.
If it's
That way for those, because for normal fractions, it's
If it's a normal fraction, if we need to divide by it, we would worry about reciprocals. But reciprocals, we don't do anything with reciprocals necessarily to simplify a single fraction. But we do look in the numerator and we look in the denominator to make sure there's nothing we can divide out of both, don't we? Just like that 2/4. We look and say we can divide a 2 out of the numerator, we can divide a 2 out of the denominator. So I can do that. Can we divide anything out of the numerator that we can also divide out of the denominator here? No, whether it be a number or a variable. We don't have either. So we can say that we have a simplified answer. I'm just going to then now write here's what I would have done with this one, okay? Not saying that yours is wrong, I just would do it just a tiny bit differently. Because this is a fraction, I would just make these guys into fractions right away. And I'd just multiply straight across the top, straight across the bottom. 2 times 1 times 1 is 2. 1 times 1 times m to the third power is m to the third power. Self, are there any 0 or negative exponents? No. Is there anything I can divide out of upstairs that can also divide out of downstairs? No. Well, I guess this is my answer then. Okay? Okay, how about 4b? You want to share with us how you did 4b? What did you do for that one? Or did the back of the book just say, here's your answer, so, and you thought, you know what, that looks like it should be the answer because I know, but I just don't really know how to show it. Anybody have something they can tell us?
Well, you could do, you could do a fraction within a fraction and make it 1 over R3 over 7.
Like this, is this what I heard? To do that? I agree, I like that. Because that's really what we're doing is simplifying the numerator, right? So the numerator simplifies to its positive exponent form, which is 1 over r to the third power. Well, now what do we do?
You can multiply by 7,
Multiply by 7,
just to get it out of the bottom.
just to get it out of the bottom there.
Just because you don't want to fraction for fraction.
Okay, so how am I going to multiply by 7? Am I going to have to, I don't get how I would do that. Because if I'm going to multiply by 7, then I really have to do that. If it's an equation, I got to do it to both sides. But this isn't an equation. So if it's not an equation, if it's a fraction, if I'm going to multiply by 7, aren't I making it 7 times bigger? Can I do that? What can I multiply by, and that's okay? 1. I can only multiply by 1. So if I'm going to multiply by 7, I would really need to maybe multiply by 7 over 7. I'd have to take both the upstairs and the downstairs by 7 because 7 over 7 is 1. And I can multiply by 1 and not affect the, so would that get us anywhere if we did that? What if we did take 7 over 7, would that help us? No, these 7s would cancel and we'd still be in kind of the same shape, wouldn't we? Yeah. Okay, well then what are we going to do? What in the world? Yesterday's notes, anybody got those out? Remember to say yesterday we had a fraction within a fraction. What did we do when we had a fraction within a fraction yesterday? Because of course I could just walk you through this, I could just write everything down on the board for you and just do it. But I can tell you what will happen in the next couple of days at home if that's what I do. If I made them accuracy assignments, we'd be here until 2020 fixing our assignments. So let's figure it out by ourselves here. What do you think we could do with this? I'm thinking about that problem yesterday where we had x to the negative n power 1 over x to the negative n power.
Or we did it now is we divided by 1. Or we took 1 over 1 divided by 1 over x.
So we took the numerator divided by the denominator. Is that what we did? So we could rewrite this as 1 over r to the third power divided by 7. Is that what that says, right? That fraction? The numerator is 1 over r to the third power. We can divide it by the denominator, which is 7. Well, then we can make 7 into a fraction by what? Put it over 1. Well, then, as long as it divides nicely, we don't have to change it into a multiplication problem. Does this one divide nicely? Both up and down? Which floor doesn't divide so nicely? The top floor. 1 divided by 7 is not 7, is it? It's 1/7. So then we'd end up with fraction again within our fraction. That would be worthless. So what are we going to do now? Multiply by the reciprocal. So we're going to take 1 over r to the 3rd power. We're going to multiply it by the reciprocal of 7, which is 1/7. And our final answer should be
1/7 r.
1 over 7 r to the 3rd. There's the simplified answer for this one. Why can I say it's simplified? Why can you say it's simplified?
Because you can't divide the top or bottom by any of them.
Can't divide the top or the bottom by the same thing, okay, what else? What other thing? You have to run through these tests. What others?
There's no zero or negative.
There's no zero exponent, there's no negative exponent, so I'm thinking they're all as well. You should be able to say we're done with that one. Okay, how about the next one, 4C? How'd that one go? What'd you do there?
G4 over 1 H6.
So we could set up another fraction within a fraction? So g to the 4th doesn't need to be renamed because why?
Because there's no negative or zero.
Yeah, it's a positive exponent, and then you said rename the denominator as 1 over h to the positive 6th power? Okay, do that. Now what? Fraction within a fraction. Write it as a division problem. Yep, write it as a division problem. G to the 4th divided by 1 over h to the 6th. Well, since there we have a fraction, let's make this one into a fraction. Does that one divide nicely, both up and down?
Yeah.
Okay, what's g to the 4th divided by what?
G to the
G to the 4th. Cool. What's 1 divided by h to the 6th?
That doesn't work.
That doesn't work. It's not h to the 6th, is it?
So we're going to have to multiply by the reciprocal.
We're going to have to multiply by the reciprocal. G to the 4th over 1 times h to the 6th over 1.
Technically, it's just G to the 4th times H6.
Yeah, technically it's just going to end up g to the 4th, h to the 6th. So it's going to be g to the 4th, h to the 6th. Because those ones downstairs, are they critical? No. Divided by 1 is, I don't know, useful step. Okay, were these the answers they gave in the back of the book? Anybody check? Remember that's what you're supposed to do? Anybody have another way you did it and you just want to share with the class that you had a different strategy? Well, I want us to then, I mean, is there a way that maybe sometimes we don't have to work this hard? Is there anything, like a little trick, a little shortcut that you are convinced of, that you've seen it happen maybe enough now that you think we can count on it? Before we move on, because I'm going to have us practice some more because that's not near enough practice on these algebraic expressions. So anybody think that they can, I guess I should leave these last two that had those negative, where we had to set up fractions within fractions and then we had to change them, write them as division problems, and then because they weren't good division problems, we had to change them to multiplication problems, and then we finally got to our answer. Look at the answer we got and compare it to what it started as in both 4B and 4C. Do you think you could be like, why can't we just do this? Because if you can't come up with that, I'm just going to have to make you work this hard. Oh, I just don't want to have to do that. Let's just Just keep working, and maybe the light bulb will go on in a little bit. Okay, let's start with this first one here. 3/4 x to the negative 2 power y to the third. Does 3/4 need to be renamed, class? No. Or leave 3/4 as it is. No reason to rename it. Only rename the pieces that need to be to help you simplify. How about x to the negative 2 power? Does it need to be renamed?
Yes.
Yes. We need to rename it as?
1 over x to the third, or the second.
Okay, 1 over x to the second. How about y to the third? Does it need to be renamed? Why?
So it doesn't have a negative or a zero.
Yeah, it's a positive exponent. It's not a negative or a zero, but we're going to make it into a fraction because everything else in the problem is fractions. So we're going to put it over 1. And now we're just going to multiply straight across. 3 times 1 times y to the third. 3y to the third. 4 times x squared times 1. 4x squared. Can we say we're done? Does it pass all the tests?
Yeah.
Yeah. Where are those 3 tests again?
Can't have a negative.
No negative exponents.
Can be divided by something.
Can't both the numerator and denominator can't both be divided by something. And what was the other one?
Zero.
No zero exponents. So it passes all 3 of those tests. So we're going to say there's our answer. Okay. Discovered yet what maybe we could do? What
Turn
again?
them all into fractions.
Turn them all into fractions. Okay. Yeah, that's kind of what we're going to have to keep doing. I think there's an easier way yet, but we'll just keep plugging away here. Okay, a to the negative 4 over b to the negative 2. What should we do?
There's like 4 fractions with it.
We're going to be 4 fractions within a fraction.
It's going to be 1 over a to the positive 4 over 1 over b to the positive 2.
So a to the negative 4 has to get renamed as 1 over a to the 4. So we're just renaming the numerator there. So it's still going to be a numerator, in other words. And the denominator has to be renamed, and it has to be renamed as 1 over b to the positive 2 power. So it's still a denominator, but we really don't have 4 fractions here. We have 2 fractions within a fraction, don't we? And fraction numerator or fraction denominator. Okay, now what are we going to do?
Turn that into like a division.
Okay, turn it into a division problem. Okay, that sounds like a good plan. So 1 over a to the 4th divided by 1 over b squared.
Doesn't work. So
Nice division problem? No? Oh, okay, then what are we going to do? Multiply by the reciprocal. So 1 over a to the 4th, that one never changes. The first fraction doesn't change. The division changes to multiplication, and we flip our other fraction. And what do we get?
B to the second power over.
Whoops, I guess I'm off paper here. B to the second power over what?
B to the
Okay, b to the second power over a to the 4th power. I circled it because I'm feeling fairly confident we can't do anymore. Does it pass all 3 tests?
You can do.
What can I do?
That's good.
What if they were a's upstairs and a's downstairs? Could I do more then?
yeah.
Yeah, a's can be divided by a's. And b's can be divided by b's, but can b's be divided by a's?
No.
No, they can't. Okay, anybody still? They know how we could have? Oh, this is so painful. Okay, well it's okay though. I can handle it. Okay, next one. M to the negative 3 times n to the 0 power upstairs, and downstairs we have p to the 0 power.
That's just here.
Oh, what's the deal here?
Well, 2 to the 0 is 1.
That is 1.
So technically,
So technically, we're saying we got here, if we just want to start there, we want to say we got times 1 and over 1, right? Right, that's, we can technically say those variables to the 0 power are just ones because we get to assume always in our lessons here that our variable is not representing what? What can't that variable be? What can't be taken to the 0 power? 0. Okay, so they're not 0. They're something else, whatever they are. Okay, so we end up with 1s, and then what happens when you multiply by 1?
Nothing.
Nothing. What happens when you divide by 1?
Nothing.
Nothing. So The only thing we're left with is that m to the negative 3. How are we going to write that?
1 over
1 over m to the third. Can we do any more?
No.
Passes all the tests?
Yep.
Well, there's one left that maybe they're holding out hope that you know what trick we can use. Anybody got it yet?
Well, it seems like for every negative one you have, it's gonna turn positive.
Oh yeah, that's our goal. You're right. Good job. We do want all of our negative ones to turn to a positive. That's the goal. Okay, well let's do our goal then. Okay, how are we gonna rewrite this one?
1 over g to the 5th over 2h to the 4th.
So the only thing that needed renaming was the g to the negative 5 power?
Yep.
Everything else is cool?
Yep.
Okay, everybody else convinced it is, besides Andrew? Okay. You're a little afraid because I'm asking you that maybe there's something else, aren't you? Well, I agree with Andrew, just so you know. Okay, so what are we gonna do next?
Turn it into division.
Okay, turn it into a division problem. Okay, so 1 over g to the 5th divided by, so it's kind of like you're just replacing the fraction bar with a division symbol, and writing it horizontally instead of vertically. And then I'm going to make this one into a fraction by putting it over 1. Is that going to be a nice division problem?
No.
Not so much. Okay, so then I'm going to change it to multiply by the reciprocal. And now I'm going to multiply across the top, multiply across the bottom, and I'm going to get 1. Anybody remember how algebra likes this stuff? What comes first? We would not write this g to the 5th, 2h to the 4th. No, we wouldn't even use parentheses.
2h to
2h to the 4th would be first and then followed by g to the 5th. Oh, you're right, they like the number parts first. When it's multiplication like this, they like the coefficient first, the constant 2 first. But then they also like alphabetical order. E, F, G, H. So it'd be 2, G to the 5th, H to the 4th. Yeah, you might as well just learn algebra etiquette right away because it's just how it goes. Okay. Anybody got that trick yet? There's just no hope. Okay, go ahead and get started on your homework. I mean, it's gonna come. I know you're gonna come in and be like, oh, it was so easy. When it comes,
Before the lesson ends?
can we know before?
Yeah.
No, I'm not giving it away. No, it's my secret. Okay. Okay, get started on your homework.